Now, we haven't talked about the cube root, and a lot of times the cube root will sometimes throw students for, a kind of loop like, oh, well, is it the same restriction as the square root? Like, I don't even know what that graph looks like. And that's good. That's why I wanted to explore the cube root in part of this explanation. When I have the square root of 4, that could be a 2 times 2, or that could be a -2 times a -2. I cannot take the square root of a -4, right? That's not going to work. The numbers have to be exactly the same. This is not going to be able to work in our real number system. What if I had the cube root of 8? So the cube root of 8 is going to be repeated multiplication 3 times. So that's going to be a 2 times a 2 times a 2. What about if I take the cube root of a -8? Well, that is going to be a -2 times a -2 times a -2. So what I want you to understand here is when you have this cube root, there's no restriction on my x. I can plug in any real number in for x, and I'm going to be able to get a value. If I had the g of x equals cube root of x here, that graph looks something like this. You can see my x is going to be defined for all x values. So it doesn't matter if I shift the graph to the right or anything else. This domain is going to be all real numbers.